With energy costs remaining volatile and high in GB and electrification accelerating across logistics, real estate and transport, behind-the-meter flexibility is becoming increasingly critical for managing electricity costs and meeting the rising demand given limited grid connections. A core component of this behind-the-meter value stack for many sites is accessing wholesale markets via P415. Check out our other videos on the topic for an initial explainer. In this video, we take a deeper look under the bonnet of P415, focusing on how deviation volumes are defined, how the baseline is constructed, and how this translates into additional value compared to a free rate time of use tariff. For our analysis, we considered a 1.2 megawatt logistics site in the southeast of England with a typical round-the-clock inflexible load profile. We evaluated adding a 4 megawatt hour 3-hour duration BESS with the site connected at HV band 3. In our baseline scenario, we applied a benchmark retail tariff from our library and included non-commodity charges, a flat hedged wholesale commodity cost, and network tariffs for the site, including DUOS and CHNUOS. Under this setup, the annual energy cost for the site is approximately £1 million per annum. In the second scenario, we introduced our battery and moved the site onto a free rate tariff, also benchmarked from our library. This tariff introduces additional price signals that encourage the battery to shift consumption away from the 4 till 7 peak price window, reducing retail and network energy costs. In the third scenario, we expose the site to multiple wholesale markets, which could be achieved via an aggregator, courtesy of P415. This allows us to quantify the incremental value unlocked through P415 participation, with the logistics sites still able to keep their hedged free rate retail tariff. So what are the baselining and deviation volume definitions for this setup? For this scenario, the site's underlying load profile is used as the baseline for P415. We define deviation volumes as any increase or decrease in energy volumes relative to the underlying logistics load profile, driven by wholesale market participation facilitated by our battery. These deviation volumes can be bought and sold by a VTP across all the wholesale markets. We ensure upward and downward deviations are both declared and priced symmetrically to ensure the supplier's imbalance position remains neutral and they are not out of pocket, a guiding principle of the code modification. Under this baselining methodology, the supplier's position is adjusted by Elexon for settlement periods with deviations upwards or downwards to ensure the supplier's physical position remains balanced. Suppliers are then remunerated by a socialised fund for deviations downward and energy that they would have hedged on the wholesale market which is no longer consumed due to our battery. For upward deviation volumes, the supplier pays into the socialised fund for revenue they otherwise would not have received without P415 activity. This methodology therefore ensures that value captured under P415 for the VTP and customer arises from wholesale market arbitrage, aligning with the intended purpose of the code modification. To reflect real-world trading conditions, we also apply forecast uncertainty to wholesale prices, capturing the imperfect decision-making faced by virtual trading parties when optimizing flexible assets. Once we've run the simulation, we can dive into the results. Looking at the relative cash flows tab, our modeling shows a total value of approximately 27k per megawatt hour for 2025, compared to our baseline scenario for a 3-hour BESS operating at this site. Around 50% of this value is derived from tariff and network arbitrage, demonstrating the significant role this simpler optimization strategy can play for behind-the-meter assets. Wholesale trading via P415 provides the remaining 50% of the total value stack, enabling the battery to respond to more granular and dynamic price signals in wholesale markets. There are, of course, other market-based revenue streams that this battery could pursue, including DSO flexibility markets, balancing markets, ancillary services, and the capacity market. If you want to learn more and understand how these additional value streams fit alongside P415 and contribute to the value stack, get in touch with Gridcog today to see how we can support modeling your sites.